All right, here we go. We should be getting a little bit faster in how to determine the products. But again, it's the same idea every time you come to a double replacement. Switch those cations. Bring one of each over. Do not bring more than one each over. And 1 to 1, and then you're going to check those charges. Hydroxide is a -1, iron is a +3, because over here you have 3 chlorines. Each of those have a value of a -1. That means then that iron had to be a +3. So here I have a +3. I'm going to crisscross those down, and I would get FeOH3. On this side, sodium was a +1, chloride is a -1. It is already balanced. Thank you very much. Now I need to use the solubility rules. If a solid is not made, I am done. I don't have to do anything else. Go to rule number 2. You should have it memorized now. Sodium, potassium, ammonium automatically makes the compound soluble. You express that as being aqueous. It exists as ions. You have iron hydroxide, all right? You go in, it's not the rule number 2, which is the only one that has a cation rule to it. This one requires you to look at hydroxide, and it tells you hydroxides are insoluble, so it makes a solid. Now I need to balance the equation before I go on and do the complete ionic. Something is not balanced. Chlorides are not balanced, and neither are the hydroxides. So I'm just going to start balancing the polyatomics on either side so that I have 3. Once I do that, I have 3 sodiums. But on this side, I only have 1 of them. So if I put a 3 in front of that, I have 3 sodiums. It also impacted how many chlorides I have. I have 3 chlorides. Go to this other side, and I do have 3 chlorides over here. But remember, I've always gone to the invisible number 1 in front of that coefficient and multiplied by the subscript. Don't ever forget to go to that coefficient that's in front of the compound when you're trying to determine how many you have on each side. That same thought process goes on when you're doing the complete ionic, is counting how many you have. So when I split my aqueouses into ions, I have 1 iron, that's a +3. I have 1 times 3 by my chlorines to give me 3 chlorines. Notice how I'm writing chlorines. I did not write it as a Cl3 with a -1. That's probably some Martian ion or something. This one over here, I have the 3 in front of the sodium hydroxide, so I always make sure I go to the front, multiply by that subscript. Same thing with the hydroxide. If you don't recognize it as a polyatomic, make sure you put the time in and you memorize those again. Leave the solid as a solid because it does not break itself up into ions like aqueous compounds do. And my last one over here is the 3 in front of the NaCl. So I'd have 3 sodium ions. Don't forget to go back to that front number to determine how many chlorines you have. The checkpoint to see if you've done complete ionic correct is being able to cancel out ions on either side. I'm going to cancel out my sodium ions that are on either side and my chlorine atoms that are on either side. I bring down the remaining ions and cross my fingers, I hope then that they're all in the solid. If I bring down any other type of ion that I don't find in my solid, then I know I need to go back up, recheck to see if I can cross anything out on either side. If I can't, it might go all the way back up to the beginning part where I'm trying to balance the compounds and balance the entire equation. So again, this is another example of a double replacement reaction all the way through to the net ionic equation. The key is to make sure a solid forms, because if it doesn't, none of these other steps below do you have to do that on the exam.